homework last night, so there's no point in going over that. We're reviewing. We got through a good chunk of 9, 8, and then a good chunk of 7, I believe, as well for it. We got through pretty much all of it. And so because of that, I want to focus mainly on chapter 6 today. I think we got pretty much through everything with chapter 7. Does anyone have any questions about chapter 7? Because remember, that has to do with the electric configurations and things like that. Welcome, Quentin. Anyone have any questions about it? Alright, so chapter 6, we're right at the top of your study sheet, chapter 6. I think we got through part of this and then we didn't get through the rest of it. Alright, so we're going to play the dice game race, just the first one to 50, because I have a long class period, so we'll just say to cut it off at that point so people don't lose hope and then they're depressed for this period. So we'll just say the first one to 50. Alright, what is the equation if you're using, we'll start, I think we started with you yesterday.
I think we started with James.
Okay, we'll start with you. Alright, what is the equation for if you're finding with the first law of thermodynamics saying what is the change of heat or change of energy? What's the equation to find it if you're working with the idea of work and heat, saying the energy is either created or destroyed? There is a Q.
Q delta, Q plus.
Work. What's still for work?
Joule. No,
What's the symbol?
W.
Alright, anyone have any questions about this problem?
I don't think I should roll with that.
It's okay, you got it. Alright, so first law of thermodynamics on page 79. Finding out what's the change in energy if you have a system and surroundings. Anyone have any questions about this? Not solve it?
What equation is
It's on page 79.
for?
First law of thermodynamics saying that energy is neither created nor destroyed. So if you have heat added to a system or work done onto the system, what's the total energy?
This is first law.
This is the first law of thermodynamics.
What chapter is this?
This is chapter 6. Alright, anyone have any questions about how to solve this?
Thanks, Hershey Kids.
Thank you. Anyone have any questions about it? Alright, so if I get a positive number answer, that'll be endothermic or exothermic, Chris?
Unit 6.
Unit 6. I'm sorry, not Chris, Ethan. If I get a
Wait,
positive
what?
number. If I get a positive number answer, will that be endothermic or exothermic? If I get a negative answer, it'll be? Good job. Well, guys. Alright, I asked yesterday what is the SI unit of energy transfer, so I'm going to skip that for right now. Alright, what is the equation if you're finding specific heat? So C equals
So Q over delta T.
Good job.
That's what I'm thinking of.
I asked this yesterday, I just want to make sure. Anyone have any questions about how to solve this?
What is that called?
Specific heat is on page 81. Anyone have
That
any
is
questions?
the equation of specific heat.
Equation for specific heat. Anyone have any
We
questions
need
about
to
how
know
to
the
solve
actual
it?
equation to solve.
Yes,
Because
this is
they're
from
going to give us
math.
problems to save it.
What?
They're going to give us problems that we need to use that to solve.
Possibly. I think
But we don't give it too much of this because this is hard to remember all of it.
keep in mind, there's not a lot of math in the most recent stuff because it's the types of bonds and types of
This is
analytic
math.
orbits. This is math. So if you're having math problems, it might be something like this. So anyone have any questions about how to solve this?
Can you have like a class after school where you can go all these things?
Oh, I can do it during study hall, but I have teachers meeting after school. So if
Of
you
course, the teacher moves on when the actually.
well, then ask me now. What's the question about it?
Well, there's a lot of words over there. There's time to be on that.
Okay.
I'm ready.
Let's say, or you can ask me in study hall. Alright, so let's see, we've already asked that one. Alright, so if I'm going from a solid to a liquid, what do we call what do we call the energy change if you're going from a solid to a liquid?
Whose turn?
I think it's yours, because Jamie just went with describing this.
Solid to liquid.
Solid liquid. So it's not melting, like what is it? It's heat of
Heat of,
it was a homework question I did yesterday.
yeah, it was, start with the heat.
There's an F.
Yeah.
F.
Heat fusion.
Heat of fusion, and then Ethan, if you're going from a liquid to a gas, what is that called?
Heat of vaporization.
Heat of vaporization.
Heat to a liquid.
If you're going from a liquid to a gas, heat of vaporization. Alright, what do you call a reaction that is able to occur without continuing outside help? S.
System.
Not system. Alright, we'll just move around because there's only 3 of you, so it'll be faster to do it that way. What do you call it if it's able to occur without continuing outside help? I think this was a homework question, I think maybe?
Say it one more time.
What do you call it if it's able to occur without continuing outside help?
Start with heat.
There's an S.
S.
Pretty sure this was a homework question.
Start is like one word.
It's one word.
She said system, didn't she?
Yep.
Is it, I don't
able to occur without continuing outside help. Alright, what do you call the measure of disorder in a system?
Entropy?
Entropy. What law says that entropy is always increasing while usable energy is
What was
decreasing?
the answer to the able to continue from outside help?
Spontaneous. Alright, but it's your turn, Chris. What law says that entropy is increasing and usable energy is decreasing? What is that law?
What's the
It's a number?
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 I just law of the law of.
Nope. Something law of something.
Is it a person thing? Is it a person?
We're in the thermodynamics chapter.
Aerodynamics law.
Okay, something law of thermodynamics. Which one? There's 3 major laws of thermodynamics.
Second law of
Good job, your second law of thermodynamics.
Gave that to one, basically.
What is that?
Okay. Second law of thermodynamics, entropy is increasing, usable energy decreasing. That is the major stuff of chapter 6 because we covered exothermic and endothermic yesterday.
Entropy increase.
Entropy increase, usable energy decrease. That's the major stuff for chapter 6 because we talked about exothermic versus endothermic yesterday. We talked about system and surroundings yesterday. I'm gonna skip over that. Anyone need anything? Anyone feel like we need to go over anything else though? Alright, chapter 5. So,
Unit 5?
what?
Unit 5?
Chapter 5.
What was the other one we just said?
Chapter 6.
I said unit 6.
Alright, chapter 5. So, we're talking about this one with the kinetic theory of matter and talking about basically the different gas laws for it. What is defined as a force per unit area? Alright, Ethan.
Say again?
What is defined as a force per unit area?
Pressure?
You know, it is pressure. What is a device that's used to measure air pressure? You should know this. Amy.
What page?
Barometer. This is chapter 5. It's page 62.
62?
62. Alright, what is the equation for Boyle's gas law? I'm gonna write them upside to make sure Quentin can see these. Okay, good. Boyle's gas law.
G. What's P?
Boyle's gas law.
P. Is it like a fraction? I'm not even gonna guess.
Alright, Ethan? Boyle's gas law.
P1, P2?
What was it?
Is it P1, P2, or P1? Is there P?
Nope.
Or B?
Which one?
P1, B2? P1, B1 equals P2, B2.
Yep, alright. So, remember this one is inverse proportional. Pressure goes up, volume goes down. Anyone have any questions about how to work this? Alright, what is Charles's gas law?
Charles, is that P1 over T1?
What was that first letter?
P1 over T1, oh, V1 over T1
P1 over T1.
equals V2 over T2?
Yep, anyone have any questions about this one? How to solve it? Alright, let's see. What is the temperature scale we absolutely have to use with Charles' law and with any of the gases?
Start with K?
Yep,
Kelvin?
Kelvin, you gotta use it. You have to use it.
You have to use Kelvin with Charles and Boyle?
Oh, well, remember, for Boyle, you're not using temperature.
Oh, okay.
Yeah, but you have to use Kelvin. Absolutely have to. Alright, now keep in mind, what is the coldest possible temperature? This is what Kelvin is based off of.
0 degrees Kelvin.
Yep, what's the other name for it though?
Kelvin. Absolute 0.
Absolute zero. And that's the reason why, because mathematically it works out to use Kelvin. So it's based on absolute zero. Alright. So, what is the combined gas law?
I get my,
Combined gas law.
Would be P1 times V1, all over T1
Yep.
equals P2 times V2 all over T2.
Yep.
combined gas law?
This is combined gas law. Making sure Quentin can still see it. Okay, good. Alright. What is the ideal gas law? Alright, Chris's turn. What's the ideal gas law? I'm gonna write it above it. No. Yeah, they can see that.
I don't know gas laws. I failed this test I got a 59 on.
Alright, Ethan, do you remember what the ideal gas law is? Alright, Jimmy, do you remember what the ideal gas law is?
Ideal gas law, it's an equation.
Yep.
No, I don't know.
Alright, P times V equals nRT.
Yes, I remember that.
Alright, so this is on page 70. Anyone have any questions about how to solve one of these? I believe if I give you this one, I tell you what R is and what the other ones are because it's been too long by this point. But
So basically, you're just finding the end.
it would be like, I'll give you everything else besides P and ask you to find
Oh.
P. Or I'll give you everything else besides T and ask you to find P. So does anyone have any questions about how to solve it? So basically for this one, if you figure out, okay, I'm missing V, move P over, and then just divide and multiply. So anyone have any questions about how to do it? Alright,
Wait, so on that, like, if you move P over, it would
So-
be under NRT,
yeah, it would be like that.
and then you cross out T.
Yep, neat. And
Alright.
so for this one, it would be N times R times T divided by P. Done. So it's straightforward, you just gotta know what am I looking for. So figure out what is the missing thing and then just plug it in. I'm gonna go ahead and erase it so it'll stay back in there. Anyone have any questions about how to solve these? Alright.
I think it's my turn, isn't it?
Yep.
I think that might be it for chapter 6.
Chapter 5.
You're right, chapter 5. Alright, anyone have any questions about that one?
So we're done with math now?
This would be like the math you need to know for it. For this chapter. Alright, chapter 4.
We'll keep writing units.
You can write unit, that's fine. In the US book, they call it units. That's probably the reason why I switch over to units, because I sometimes forget which which term they use for it. Alright, what do you call, alright, what is a symbolic representation of a chemical reaction? It's your turn.
Yeah, it is.
So if I write it on the board, what do we call it? A symbolic representation of a chemical reaction.
Which term?
C.
C?
Yep.
Chemical equation?
Yep, chemical equation. What do you call the stuff to the left of the arrow, Ethan? In a chemical equation.
Alright, reactant,
You're done with stuff on the right. This is really easy.
reactants and products.
Yep, okay, just making sure. Alright, what is the law that says that the sum of the masses of the products must always equal the sum of the masses of the reactants?
Is it law of conservation of energy or law of conservation of mass?
Law of conservation of mass, say, you know, what you got. Alright, balancing equations. This is definitely on the exam. Anyone have any questions about how to balance an equation? We practiced a bunch of it. Does anyone feel like they need to go over?
Wanna do one?
You wanna do one? Alright,
I was a beast at these, so I'm not even worried about it.
what?
I was the best at these, so I'm not
Good job.
even worried.
Alright, so let's say you have, alright, Ethan. Alright,
I'm gonna write
I'm gonna make sure I copy this down correctly.
So I have a example on here. Cause I'm gonna study off of this sheet I'm writing.
I'm gonna slide this down so I find it. Yeah. Okay, good. Alright, so Ethan, how would I balance this? What do I do?
Alright, use accepted. Okay, so, I guess we start with iron.
Iron? Okay, how many ions on the reactants?
One,
Alright, how many products?
3,
How do I fix it?
put 3 before Fe,
Which one?
Fe,
On the product side or on the reactant side?
on the product side. Reactants,
Okay.
on the left side.
Alright, so that's Fe. Alright, hydrogen, what do I do, or oxygen, whichever one you wanna do next.
Hydrogen,
Alright, how many on the reactant side?
2,
How many on the product side?
2,
Is hydrogen done? Yay. Alright, oxygen, how many oxygens on the reactant? How many on the reactant side?
1,
How many on the product side?
4,
How do I fix that?
put 4 before the H2O.
Alright,
And now it's unbalanced.
okay, how do I fix this? We gotta go back to hydrogen.
You put a 4 before H2. Or 2. You put a 2 before H2.
Alright, how many hydrogens are right here?
So you put a 4 before H2.
Wait, how many hydrogens are right here?
8,
There you go, down over there.
4 H2.
There you go. Alright, so is everything balanced now? Alright, you got it? You good?
I think so.
Alright, so, but that's how you balance really quick. Anyone have any questions about how to balance? I will look at it really quick for you. Alright, so make a note though of how to balance. Alright, there are 4 different types of reactions. What do you call the type of reaction doing whenever you put two substances together and get a new substance?
Is it like combination reaction?
Combination. What do you call it if I have one substance and it decomposes or breaks apart into 2? decomposition. What if I have a substance like this, honestly, whenever I start off with a single element, and it takes the spot of another one, and it kicks it off, what do we call that? What do you call type of reaction where I start off with a single element, it kicks off part of the compound and takes its spot, so where the compound, the first element is left by its lonely only. Single displacement. What do I?
The one Chris had?
Yeah, decomposition.
What do the next question's gonna be?
Yep. What do I have if I have two compounds, Jamie, and both of them end up swapping partners?
Double displacement.
That's double displacement.
What pages are these on?
This is all chapter 4, balancing equations. The different types of reactions are on page 52 through 55. It gives you like a whole bunch of examples. Alright, what do we call the reactant that determines the amount of product that can be formed? So what do we call it if you're gonna run out of it first?
What's your
L.
no?
L.
Limited.
Close enough. Limiting reactant. Limiting reactant. Alright, that is most of chapter 4. Alright, chapter 3, if you want to go backwards a little bit. Like you want to say chapter 5 and go forward. Alright, there are, what do we call the numerical relationships between elements and compounds? I think you just use limiting reactant, so it's Ethan's turn. What's the weird word that means it's the numerical relationships between elements and compounds? S. Really funky word.
Chris. I don't know.
Looks like it's Jamie's turn though.
But you said it was my turn.
No, you didn't know it, so it's going over to Jamie next if you don't know.
Oh, it was just her turn now, and you went to me.
No, he got limiting reactant.
You said she did.
I'm sorry. She got double displacement, he got limiting reactant.
And,
Right?
What is it? Between two reactions?
What is the numerical relationship between elements and compounds? What do we call that branch of science, or branch of chemistry? It's a really weird word.
Oh, I know it.
Okay, we can go back to you. This is your original question.
Stoichiometry.
Stoichiometry. It's on page 37.
Wait, is he gonna roll for that?
Because it was his question originally. Alright, so
I've got my 3
how do you name a binary molecular molecule? So if I have something like this, how would I name it? It's Ethan just went switcher, is what I was referring.
Would be nitrogen dioxide.
Good job. Alright, you have any questions about how to name these? It's on page 38 or 39.
Nitrogen, wait, what?
Dioxide.
Are we gonna go over that thing you guys memorized about the compound names, or about the names of the elements?
What page?
Fe equals iron, like that, are you gonna go over?
I wasn't really planning on it because
Is that
we use them
convenient?
so much, like, this is iron, like, we use it so much, I don't really plan on going over it.
Is it on the exam?
I am gonna ask you to name, I believe I have one question of name, like a binary molecule, name an ionic compound, I think I asked like one more thing
What?
about it, and then that's it, and I move on.
What page is that? Like nitrogen dioxide and naming on.
Okay, the naming the binary molecular compounds is on page 38 to 39. Alright, so page 40, I think is maybe what you're getting at for it, with naming the different ions. So if I have something like this, if I have something like this, how would I name this one because it's ionic? So this is Chris's turn.
Aluminum, tetrachloride, or no, trichloride.
Alright, so with the ions, do you give the prefix? So we'll just do the name.
Fluoride.
Aluminum fluoride. Alright, anyone have any questions about how to name them? I think I picked the easier one, so don't spend a ton of time on it, but go through and just review really quick over how to do it. It's on page 40.
Aluminum fluoride?
Aluminum fluoride. You don't use the prefixes for them. Alright, but keep in mind if it's something like, a harder one. If it's something like, we'll do this one. If it's something like this, how would you name it?
Copper dichloride, or is that copper?
Yes, copper, this is chlorine. So how would you name it?
Chloride?
Alright, so remember copper, it can exist in multiple forms. So if copper is giving away 1 electron, what's the full name for it? Because remember, with the ions, you have to say like the charge with the Roman numerals. So how would you name it?
Is it like 1 copper,
Close
chloride?
enough. Copper 1 chloride.
Copper 1.
Okay, I don't even remember if I get that hard with it, but it's something just to look over it. So just double check it, it's on page
Copper
40.
1?
Copper 1 chloride is how you would name it. I think it's page 100, not 100, Jimmy. 40 to 41. Are you raising your hand, Jimmy? Okay, just making sure. Alright.
41?
What?
41?
Yeah, 40 to 41. Alright, what is Avogadro's number, Jimmy?
It's at, is it the like 3.0, no, I know that's not it.
3 point. I think you're thinking of pi.
Say it one more time.
What is Avogadro's number?
I can't remember.
Alright, Chris?
Isn't it like 7 point,
Mm-hmm.
what? Huh?
Avogadro's number.
What is the first, number?
6.
6?
Mm-hmm.
6.72? No, 6 point. I literally, 6.00
Oh, there you go.
times 10 to the 28.
20 what?
28. 27. And not times 10 to the way lower,
Not super lower.
times 10 to the 21st.
Was that 21st?
23rd.
23rd. 6.022 times 10 to the 23rd. It's on page 43.
6.0022?
Oh, 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. Alright, if I'm finding molecular mass of, say, this substance, what do I do?
What page is that again?
Avogadro's number is 43.
Right.
If I'm finding molecular mass, what do I do?
You find how many protons or how many
Molecular mass.
how many moles or something like that? I don't know.
Alright, Jimmy?
Would you look at the periodic table?
What am I looking at?
The atomic number?
Yep, so for example, copper, I did not work this one out ahead of time. So copper starts off with 63.55, and then chlorine is 35.45. So this would be what, Ethan?
Yeah. Molecular mass. Copper is what?
Copper is 63 point, that's a really messy 63.55, and then chlorine is 35.45.
35.45? And then you add them?
Yep.
Current numbers on it, 34.
So I can do this quick, I just don't want to.
63.55 plus 35.45.
Mhm.
143.55.
What was it?
143.
143 point what?
55.
Pretty sure it should be 0 and 0. Let me check.
Nope, hold on.
I was like, you should, it's 5 foot.
I accidentally hit.
I'm about to say, okay, I think you did something wrong.
63.55 plus 35.45?
Yep.
99.
Oh, 99?
Mm-hmm.
You sure?
That's what it is.
Okay, I got it right now. Yeah. Alright, so for this one, what would be the units for this? If it's molecular mass. Okay, you've been long enough. So Jamie, what would be the units for this?
Would be the little u.
Yep, because remember this is molecular mass. So sig figs would be what?
2, 4.
Before, because remember it's addition, so since this is the last numbers, these also count. So this would be the full answer for it. Anyone have any questions about that?
Addition and subtraction. What is the sig figs? What is the jig?
Alright,
And then what is it?
subtraction, you go at the place, so it's the larger, it's the least significant number. So if I had something like this, since this one ends at the hundredth,
By place?
yeah, it's by place.
And then multiplying
It's
and dividing.
number,
Multiplying, dividing is number.
is number. Alright, Chris, what if I asked you how to find the molar mass of copper chloride? What would you do?
What you just did?
Yep, well, the same thing, but what's the difference? Between molecular mass and molar mass, there's one difference.
Oh, moles per unit.
Yep, grams per mole is what you're thinking of, but yes. Alright, anyone have any questions? So pay attention on the exam.
I won.
Did you really? 50?
I'm just gonna ask, was I supposed to roll for the last one?
Yeah. Okay.
I got 54.
Yay! Alright, reset. So anyone have any questions about how to do this? Because I believe I do ask on the exam, and I don't remember which one it is, if it's molar mass or molecular mass, but anyone have any questions about how to do it? This is one of these is on it.
What happens when we finish all, what happens when we finish the review before time's up?
We're gonna go back, and we're gonna make sure we covered everything. Unless you have a question about math. and this is time to ask you a question on that.
What's the name of the G/MO? Yeah, or the G/MOL.
Grams per mole.
Grams per mole, that's the units for it.
And for what, like the equation?
Molar mass. Molar mass. So if I ask for molar mass, it's grams per mole. If it says molecular mass, that's just the unit.
That's the only difference, right?
That is literally the only, so if you look at the equation, you say, okay, molar mass, grams per mole. If it says molecular mass, U. So that is literally the only difference between them. You just add them up and figure out, okay, which one is it asking? So slow
Well-
down and read to see what that one is.
Will we be getting a periodic table on this?
Yeah, if I give you, I believe it's the one that I've been giving you. I believe that's what you need it for this one.
We need a calculator.
Yes, for your calculator.
Yeah. If you don't, you won't finish in time.
Oh, you'll probably just wanna cry.
Oh, I already wanna cry, so.
Yeah, it's okay.
Yeah, you'll be given a periodic table for this one. Alright, I believe that is it for chapter 3. Anyone have any questions about chapter 3?
I really haven't read anything else to do about it.
That's good, I guess. Don't leave. Alright, so going back into chapter 2 now, because we're almost getting through it. Alright, what is the energy of motion? Reset all your
Going
points.
back to where?
Chapter 2. Alright, so we'll just reset everything. So crystalline, we'll start with Jamie. Alright, Jamie, what is the energy of motion?
The energy of motion.
Yep.
Kinetic energy.
Yep. Alright, what are the 3 common states of matter, Chris?
Liquid, solid, and gas.
Good job. Which one has the least kinetic energy?
The solid,
Which one has the most?
these.
Good job. And then what's the 4th one? What technically has the most
Plasma.
overall? Good job. Okay, go. Roll. Alright, what do you call a group of 2 or more atoms that are linked together by chemical bonds to form units? What do you just call 2 or more groups of atoms that are linked together? What's that general term for them? So like, what do you call?
Let's just start with,
M?
I had it on I forgot.
It's okay. Jamie?
Molecules.
Molecule, and then what do you call it specifically is 2 or more different ones?
Compounds.
Yeah, roll your dice. Alright, I think I asked you, no, I don't think I asked you to name the elements, because I asked you to name stuff like this. Does anyone have any question about like the atomic symbols for them?
How example? Like, name?
Like the name, like okay, if I give you H, what is H?
I do.
Okay, make sure. Alright,
I've already had it.
yeah, I was like, we've done these so much, I don't really feel like we need to go over it. Alright, make sure what's something important in here. Alright, what determines the atomic number or the identity of the element? What subatomic particle? Protons. Alright, so if I change up the number of protons, what happens?
Oh, I thought you were looking at me.
Sorry, you can.
It's different.
It's a whole different element. Alright, what is the neutral part of the atom?
The neutron.
Neutron. Oh. What is the negative part of the atom? I'm just gonna go through these. I know. You gotta know it. Which one? What's the positive part?
Proton.
Proton. Alright, so if I change up the number of neutrons in an atom, it's still like the same type of element, but what's it called now? Because it's a different number of neutrons.
It's an isotope.
Isotope. What do I call it if it's the same element, but I change the number of electrons?
What's that?
I.
I. Say again?
Alright, so if I have the same element like carbon, but it's carbon that's either gained or lost electrons.
She said isotope.
She said isotope for number of neutrons.
Would it not be, is it ion?
It's just on. Wait, what?
Ion.
Ion. Alright. What do you call it if it's lost electrons?
I thought
Specifically.
877, or 8757. Big luck.
Say it again.
So what do you call it specifically if it's a type of ion but it's lost electrons?
Seven.
You could
Let's
say
just start
positive
with-
though. It starts with C.
You can,
Okay.
Can you repeat the question?
What do you call it if it's lost electrons? What type of ion specifically?
Cation.
And what's the other one if it's gained electrons?
Anion.
Yeah.
That's why I said it was an animal.
It's been a long time. Alright. Covered all of that.
cations are lost electrons.
Cations, loss of electrons because they're positive values. Anion are negative because they've gained electrons. Alright. what is the mass number? So atomic number is number of protons, mass number is
Number of electrons, neutrons,
neutrons and
electrons, protons.
protons. Remember, it's neutrons and protons together make up the
Easy.
mass number. Alright, I think that's it for chapter 2. Yeah, chapter 2's done. Alright, chapter 1. This stuff should hopefully be really basic, and then we'll go back and we'll hit the most recent stuff, since that's a good chunk of it. Alright, there are 5 branches of chemistry. What is the chemistry that deals with carbon?
Is it my turn?
I think so. Isn't it your turn or is it Ethan's turn?
Who? Was it you just answered?
What?
Was it you that just answered? Did you just answer?
I don't remember which turn it is.
Miss
Hold on, let me think.
Anderson.
He didn't say cation, it went to Jamie. She said cation and anion. And then,
You said mass number, it's Ethan's turn.
yeah,
Ethan hasn't gone yet. Alright, Ethan, what is the area of chemistry that studies carbon?
What's this spelled with?
Oh,
Organic?
organic chemistry. What do you call everything else besides studying carbon?
Inorganic.
Inorganic. You're still not yellow. Alright, what do you call this study of life with chemistry?
start with an N.
Study of life. There's a B.
Biology.
Close enough. Biochemistry. Bio. Alright, what is the chemistry whenever you are analyzing a substance?
Analyzing.
Analytical. And then what is chemistry whenever you're doing with physics and chemistry?
Is it physical?
Yep, physical chemistry. What are the 3 major steps to the scientific method?
Okay.
I know.
I accidentally just looked at there.
It's okay, my junior high is all goes, here we go. Observing,
Hypothesize,
good job.
and theorize. No, observe, hypothesize, and prove. Experiment.
Experimenting. Alright, what do
Oh,
you,
wait.
alright, so a hypothesis is a tentative explanation of a natural phenomenon. Alright, once a hypothesis has passed your experiment and other people's experiments, now what is it called?
Scientific law.
Not scientific law yet,
Law.
not law yet.
Theory.
Theory, and then what does it come up against test of time?
Scientific law.
Yeah, okay. What is the language of science?
Mathematics.
Yeah.
I have 43, I hope y'all hurry up.
Alright, so accuracy and precision, which one's which?
Accuracy is the ability to do the same thing over and over. Precision is the ability to hit the same spot.
Final answer?
Accuracy is the ability to get close to what you want. Yeah, so it's like hitting the 50, but you can't do it every time.
Okay, so accuracy is hitting the mark, and precision is
Hitting the same place every single time.
good job, because you flipped it the first one. So I want to make sure. But yeah, so accuracy is actually getting to the bullseye. Precision, make sure you hit that spot over and over and over
I
again.
have 48 right now.
Alright, there are 2 different types of exact numbers. Name them.
Exact numbers?
Exact numbers.
Which one start with?
Like I know there's 3 of you in the room. Besides me.
Counting.
Counting numbers, and then how do I know that there is 100 centimeters in a meter?
Measure. Let's start with
D.
determine.
Okay, it's defined as, okay, there's 100 centimeters in a meter. Alright, anyone need to go over the SI prefixes again? So like what kilo, milli, centi mean? It's on page 7. Okay, skipping that then.
I need 10.
Alright, what is the force of gravity on an object? Wait. Alright, what is the SI unit of mass?
What's our
G.
G? Gram?
Gram. Alright, what refers, what? Good job, Chris. Alright.
56.
We'll say whoever's ahead whenever I finish going over this, and then we'll see about going back through all the most recent stuff again. Actually, I'm about to be done. Well,
We have like 25 minutes.
yeah, we do. Alright,
Darn! Are we gonna be done early?
what?
We're gonna be done early.
We're gonna just review until time's up.
Can we do
We're gonna
darts?
stop.
Can we do darts?
I'm gonna move very fast.
We always
Okay.
can do.
Okay, I just wanna make sure. We'll go ahead and try, and then we'll go ahead and move it up to the ceiling. Sorry, question. Alright, so,
We're gonna start now, or?
I'm gonna do it till 10, and then we'll swap over, because I wanna make sure we're sure we get through everything. Alright, so, whoever's ahead in the next, like, 5 to 7 minutes. Alright, so, what term refers to the compactness of matter? We'll start with Ethan, because I haven't started with Ethan yet.
Density.
Alright, what is the SI SI unit for volume?
SI unit for volume, liter.
Yep.
Is this new score?
Yeah, you scored.
Wait, what?
Oh, reset cause Chris won.
Oh, and then what was the question?
What is the SI unit for volume?
It's
Liter, is what she said. Alright, anyone have any questions about significant figures or how to work them?
Can I go over them for a second?
Yep. Alright, let's say I have a number, let's say like this. Alright, how many sig figs, Jamie? Oh, you know, we'll let Chris answer it. How many sig figs?
oh, I know it.
I know, so wait, you can roll.
4.
Alright, what if it's a number like,
Can I roll?
yep. I'm not gonna make mine up. Alright, what if it's a number like this? How many sig figs?
2.
Sure?
1.
Yep, because remember, zeros to the left do not
Zero.
count even if there is a decimal point. So they only count if they are to the right. Alright, if I were to add these up, how many? Alright, so if I were to add these up, let's see, to what place should my answer round to?
The 10th place?
Here?
Yeah,
Why?
because you want it to be as short as possible, so.
Alright, well this one ended in the hundredths, this one ends in the thousandth, so where should my answer round to? Because addition and subtraction, you go by place.
Oh, I see, okay. The 1,000.
Here? But this one ended here, this one's slightly larger.
Hundreds.
Hundredths, so that one went around to this. Alright, anyone have any questions about that now? Alright, so have this. Any, okay, do you have any questions more about sig figs or does that cover the
I
basics
think
for you?
that's good.
Okay, let's say that covers the basics for them. Because it's all non-zeros, there's never beginning, middle. So if I were to stick another 0 here, would this one count? Why?
Because it's past the important, like, numbers.
But there's a decimal point.
Okay, so would it be counted?
It would. So go back over the rules on page 12 for it. All non-zeros are always significant. Zeros to the left never count, even if there is a decimal point. Zeros to the right only count if there is a decimal point. And then of course zeros in the middle
So
count.
it's possible to have 0 sig figs.
I guess if you were like that? I guess. I mean, I don't know why you would do that, but yeah. Alright. I believe that is everything for chapter 1. Alright, anyone have any questions though?
Too easy.
Yeah, I know. But you know, you've been reviewing this stuff for a while. Alright, take it back over to do the
Are
most.
you switching to darts?
Well, I'm gonna go till 10:10 and then we'll swirl. Alright, 10:10.
Ben 10.
Almost. Alright, there are 3 different types of chemical bonds. Name all 3.
Metallic ionic.
Good job. Alright, there are 3 different types of intermolecular forces. Name all 3.
Hydrogen bond. Dipole bond.
Good job. Alright, which one is characterized by the attraction of the ions together?
Oh, I was talking about the chemical bonds?
Yes, it was bonds.
The attraction?
One is positive and one is negative.
Would be covalent?
Final answer?
Yes.
Yep. Alright.
You said not metals, no?
Nope. I said positive and negative, like cation ions and anions. Which one is defined by those holding each other, like being attracted to each other?
Where's the word?
Yep. So ionic, covalent, and metallic.
Ionic.
Ionic. Alright.
You
What?
said that really weird.
Well, you have to know what the idea of it's the cation ions and anions that are holding together. It's the
Negative,
charges.
positive.
Yeah.
I feel like
Yeah, but you have to go off the word and then the numbers on the exam. So that's the reason why we're going over it. Alright, so what type of intermolecular force is in every type of molecule, polar or non-polar?
Wait, what?
What type of intermolecular force is in every molecule? London. Alright, so if I have a substance like, I'm gonna run out of space. Yeet. So if I have a molecule like this, alright, what type of shape would this one have? I'm sorry, dude, I gave you a really hard one. Now go ahead and erase this.
Would it be the trigonal pyramidal?
Good job. It would be this. Let's see if I did. Yep, I did grab the right one. polar or non-polar?
Polar.
It would be polar. Why?
Because it's not the same all the way.
Good job. So, what type of intermolecular forces would be on the inside of it then? Are you guys holding one molecule to another?
Me?
It is polar. Yep.
Dipole
And?
in London.
Good job. Would it have hydrogen?
No,
Why?
because it's not hooked to a hydrogen bond.
Yeah, so there is no hydrogen, and so because of that, it can't have hydrogen bond. Alright, what do I, let's see, Ethan just went, so is Jimmy. Alright, so Jimmy, I'm gonna guess one more question. Alright, what do you call, it's gonna have something about it, I don't know what it is. Oh well. Alright, what type of bond would be between nitrogen and fluorine?
Between nitrogen and fluorine, like polar and non-polar?
Oh, like covalent or metallic.
Oh.
You're right, it would be polar.
Let's see. Would that be covalent?
It is covalent. Alright, now we can talk over. Alright, so, thinking over it, yep, who has, we'll say 15 or more? I think I went through 3 of each other, 3. Alright, who's got 20 or more?
20.
Alright, how many you have?
26.
Alright, either one's over each can for. Alright,
So is my question?
what?
My question?
Yeah. Alright, there are different types of solids, what are they?
Amorphous and crystalline.
What's the difference? You're right, but what's the difference between them?
Crystalline is not random. Amorphous is random.
Good job. Wait, give me German.
Too late.
Nope, German. Sorry, that was a lot. I'm very sorry. Did not mean to come up that much.
Put it in your coffee.
There's no more coffee, I think, at all. Okay,
Oh,
that's gonna hurt.
my nose.
That's fine, don't do that.
This is why your ears hurt.
Smells good.
Alright,
That's not why my ears
alright,
messed up.
alright.
Oh, that stuff is, that can make you high.
Yes, so don't do that.
Oh!
6. Alright, Ethan's turn. Alright, Ethan, there are 2 different types of close packing that make it as compact as possible. What are they?
Base and hexagon.
I got the
SEC.
base-centered cubic and then hexagonal close packing.
Can I just stay standing up?
Oh,
As long as you're not distracted. What?
That could be it.
I think that one might be a multiple choice or a match. I don't think you have to worry about
Wait,
it.
there's a Columbus, Mississippi?
No.
I guess. I don't know every single city.
How many?
If it's on the map, it is.
There's a Columbus, Mississippi, a Columbus, Georgia.
Close to
I know
I
there's
would say I get Columbus, Ohio all the time, but that's because it's the capital.
No, every time I tell someone I'm from Columbus, they're like, Ohio? I'm like, no,
No, it's
Georgia.
because it's the capital. Alright,
Yeah.
what is, okay, we're gonna kind of see what do you call it whenever you have the atoms whenever they vibrate back and forth between 2 or more atoms?
Between 2 or more atoms?
Yeah, what do you call it if you have, what?
Partial charge?
Oh, what do you call it if you have the electrons if they're not locked in, so they're moving back and forth?
Delocalized?
Okay, that's the name for the electrons. What do we call the situation?
Delocalization?
Good job. Yep, delocalization or resonance.
What is the definition of that again?
If you have a bonding situation in which electrons are shared by more than 2 atoms, so it's moving back and forth between them.
I thought Puerto Rico was some country.
Nope, it's part of the United States.
Interesting.
Alright, Chris' turn. Alright, Chris. What do you call it whenever you have a substance that is composed of billions or trillions of atoms that are covalently bonded together?
You start with
C.
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 Oh, C.
There's a C.
Say it.
What do you call it if you have billions or trillions of atoms bonded together into a single unit by
Covalent
strong?
network.
Get up.
Can I also be standing up?
Sure. I'm not distracted. Alright. Ethan, how many electrons are being shared in a single bond?
2.
Alright, now how many in a double bond? This is easy, so I'm going through it all.
4.
And how many in a triple bond? Yeah, just making sure. I wondered where they went. Thank you.
I'm not grabbing Jamie's because girls.
Yeah, it almost went there.
Alright.
It went.
What is the rule that says they try to get 8 valence electrons?
The octet rule?
Octet rule.
I guess I'm a trendsetter because I stand up and everyone stands up.
You'll have been sitting for a while. This class is long, so it is.
No, I would have fought. The reason
The
I
other
had to
class
stand
was
up-
an hour and
The
20
reason I have to stand up is because in English I almost fell asleep. I was about to fall asleep.
Okay.
Not because you're boring, it's just because of how long I was sitting.
I know.
It's
That's
because
why I
how
like
long he
to
stayed up.
I
Alright.
know, I went that.
I know.
So, what corner has the largest atoms?
Where's that?
Largest atoms.
Um,
Talk about the electron cloud. Bottom left. Alright, which element is the most
Wait,
electronegative?
is that 10?
That is tin, because the whole metal is predominantly in tin. Alright, Ethan, what element is the most electronegative?
What element?
Element specifically.
Lori.
Lori.
Taking home by 1.
Alright. What corner has the most negative electron affinity?
Electron affinity, most negative, would be the bottom left.
Final answer?
Yes.
Nope. Alright, so Chris's turn. Which corner has the most negative electron affinity?
Top left. Or top right.
Why?
say?
Because 4 rooms there, that's on the
Okay, keep in mind though that those are the ones to where they are stabilized by adding on electrons, because that's the definition of electron affinity. I'm gonna start asking for definitions, but I'll figure it out.
Well, I know how to find them.
Well, you know what you're asking though. Alright, what is ionization energy?
What?
What is ionization energy?
It's the energy of detracting electrons.
Final answer?
Yes.
Nope.
You're getting it right. That's right.
What ionization energy?
It's
I swear that's it.
how many ions it has.
Nope.
It's the ability for an atom to pull in.
Nope. Alright, write it down. Ionization energy is the energy required to remove an electron.
That's what I said.
Take it off. You said red.
That's
I
a
heard
subtract.
red.
That's a
I
subtract.
heard that. I'll ask you another question in a minute. So, energy required to take off an electron. So that means it would be bottom left because those don't want their electrons. So they have the lowest ionization energy. Alright, what is electron affinity, Ethan?
It's the ability to add.
That is the ability to add an electron. There you go. Alright, what do you
That's
call
only one.
the ability?
No, it's not. It's only 18.
What was it?
It's 18.
Alright, what do you call the ability of a chemically combined atom to attract electrons to themselves?
What does it start with?
E. That's like everything in this section.
Electronegativity.
Electronegativity.
She was zooming.
Straight up.
You're right in the same spot.
How many
That is
valence
position.
electrons are in group 17? Hey, I didn't ask this previously because I had that question.
We all should get one of those.
Okay.
It doesn't stick to that.
Watch me get it wrong.
Yeah, because it's a little. She has to close the one. Be patient. Don't dent my board. Okay. Alright, how many valence electrons are in group 2?
Now the left just a little bit.
2.
2.
Did you still put them up there?
Maybe the first time I actually wanted dark green.
Alright,
Never mind.
how
Don't
many
speak to
valence
it.
electrons do the chalcogens have?
We still have a little bit.
Cheater. What is a chalcogen? Okay, it's group 16.
Yeah. 6.
Yep. So do you know what a
I
chalcogen
remember
is?
6 was 16. Is that or is that?
It might fall in a second, so go ahead and throw it in, and then it might shift. So we'll look at it.
Oh.
Oh, I was kind of hoping it didn't. Alright.
3 to 3.
This is 3. It's predominantly on 19. Alright, so what do you call the up and down columns on a periodic table? G? G. What do you call the up and down column? We don't say column 1, what do we call it? Not too loud, because remember Quentin can hear it. Okay, so instead of saying column 1, we say it's something 1 instead.
First with a G.
Yep.
Group.
Alright, and then what's the back and forth line?
Bro. Column. Period.
Period.
Letters.
Not
Ouch.
too hard. happens on the exam.
Principal.
Alright, and what's described?
Electrons. Level. Electron. Energy level.
Energy level.
There's a London in Canada?
I guess so.
That's so great.
Alright, what is the name for the second quantum number and what is it described?
The chef shell quantum number is the shape.
Yep.
We have 45 states, right? I'm joking. No, for real, I thought,
We have 51 states.
Not yet.
I thought Nicaragua
They're
was
gonna
like
make
a
Washington.
religion.
60.
Nicaragua, however you say it. I thought it was a religion.
That's right.
So I'm not joking.
Alright, what is the third quantum number? What is it described?
Third quantum number is the magnetic quantum number.
What is it described?
Describes orientation.
Good job.
Boom!
I think people better about life. Alright, what is the fourth quantum number and what is it described?
Me and Ethan about to be better. What you got?
I don't know.
It's your turn.
Oh, it's my turn? Third one number?
Fourth quantum number.
Fourth?
Mm-hmm.
Spin.
And what's described?
Clockwise or counterclockwise?
Yep.
Hey, can you
It's not going better.
Alright, we'll say, because it looks like we might have time to do 2 rounds of this. So we'll
That's
say
fine.
the first one to 100.
Oh, it's like lagging.
But this is where it's actually recording this. So you can't do it. Alright, what is the, make me nervous, good. What is the principle that states that no 2 electrons in an atom have the same set for quantum numbers? Paul exclusion principle.
Oopsie daisy. Oopsie daisy.
Well, it's 19. Remember, first one to 100. Alright, Ethan. No, it's Chris. What is the principle that says they will occupy the lowest orbital available as a book? A.
A?
Okay, make sure you can spell it, but yes.
I don't know how I did that, but you know.
Not too hard, Chris, really. You're gonna have to get banned if you don't do it, if you do it too hard.
That's gonna be bad for you.
I don't want it to dent my board. Alright, what is the rule that says when a subshell is being filled in the P, V, or F, it'll fill 1 in each orbital for it
Let's
goes
start
up
with
8.
Humsel.
Hundred.
Are you kidding?
Apparently, the board's
It was on 19 and it fell off.
Okay. What do you call the tiny bundles of packets of energy of light?
Photons.
Photons.
How much do you have?
Alright, what is a device that's used to measure heat flow?
Oh, Chris, do that.
He's outing, I guess.
57.
It looks like the avatars in video games, whenever like you're not moving anything,
What
they
is
just start doing random stuff. What is a device that's used to measure heat flow?
Start with C.
Yep.
Thermometer.
Okay, calorimeter, but yes.
Calorie meter.
If that's to remember, yes.
Thanks for that.
It's kind of how the way that Darwin
Alright.
works.
I erased it. What's the name for this equation or law?
Let's start with
C.
Charles.
Nope.
No, combine.
Combined gas law.
Charles Manson.
I never said Charles.
Oh, I'll show you.
I need
in a second.
14. Sorry,
Not
I
too
broke
hard.
Holy!
I didn't mean to look. Oh, is that 14? That's what I need.
Holy sweet Mary and Joseph. That's
I need 14.
That's 9.
I need 14. Dang it.
You need exactly.
I need 14. I didn't mean to throw it that hard. I don't want it just left my hand.
Alright, so
They go
question.
fast.
Ethan, scoot over a
I need
little bit.
5.
Scoop!
Scoot, so I can zoom down for you. Oh my, okay.
I'm over here.
Alright, so Quentin, I asked what this law's name is. Alright, nope, it's your turn. What is the name for this law?
Oh, that is Boyle's law.
Boyle's law. So it's P1 times V1 equals P2 times V2. Good art, Jamie. I'm sorry, Jamie. Alright, what is the name, Chris, for this law?
Oh, sorry. Let me see it. Ideal gas law.
Ideal gas law.
You look
Roll
at
by tomorrow.
I'll look at mine.
I'm using it first.
Alright.
Is that
12?
13 or
What would
5?
be the example of an
That's 12.
exothermic?
That's 10 and 12.
Ethan's turn. What's the example of an
There's no way. Count 'em.
Ethan? I mean not Ethan. Chris, were you cheating?
No.
Okay. Are you sure?
No, I actually don't remember.
Okay, so what?
What is an example of an exothermic process or an exothermic reaction?
X is 10, 50. What is it?
Give an example.
Exothermic?
Yep.
Ice?
Ice
No.
melting?
No.
Okay. Remember that one's endothermic because the ice is absorbing heat. Give it. What's an example of an
A
exothermic?
stove!
Okay, so like burning logs, anything that's basically like producing heat.
A stove.
Throw your dart.
Give me those.
So a hot stove, burning logs, firecrackers, anything like that.
I win. That's all I need, 5. I need 5.
For real?
I'm
Not
100.
cheating?
Oh, shucks, Mr. Krabs.
Alright, we'll go ahead and restart. We'll
I
say
had
whoever's
exactly
ahead
100.
in the next like 10 minutes.
Exactly
That's about
100.
time we
Reaching
have.
out at
35.
30, right?
35.
Mine says 35 when I counted it down.
Yoinks, Mr. Creeps.
Alright,
100.
Jimmy. Good job. Alright, Jimmy, what's an example of an endothermic process or an endothermic reaction?
Would be like ice melting in a glass of water.
Yep, so like ice melting, evaporation of water, cooking meats, anything like that is endothermic. Alright, so ice
very
melting,
Yeah, no.
Very very
ice melting, evaporation of water, cooking meat is all examples of what? Chris? I literally just asked Jamie, that's why I'm asking you to make sure that I'm sure you were paying attention. Final answer? Like final answer?
Is that my question?
Basically.
What's the next thing?
What, so, melting ice, evaporation of water, cooking meat, those are all examples of what? Endothermic or exothermic?
Endo.
Good job. So
That was
charts.
fast.
Make sure you pay attention.
You didn't vote that hard.
Alright, how many valence electrons do the transition metals typically have? Good.
I don't want to get behind them.
Whoa, wait.
Okay.
I really thought Chris was about to die.
I wouldn't
I'm
want to
gonna
do
have to
that.
take Chris down to the office and he's ready for a phone call.
And Ethan would have gotten a suspension.
We would have gotten in trouble for sure.
I would have got suspension for
Alright.
abusing students. I was gonna throw. I was waiting for you to get it. I was like,
Yeah, we already-
you okay?
Take my point. I'll play point guard.
Oh, what is
You
the
put one. I got
measure?
you, dude.
Okay, Ethan just went. So what do you call it from one corresponding point on a wave to another corresponding point?
Trust me, I know Ethan.
Wavelength.
I got you, dude.
What was my question, Chris? 'Cause I want to make sure Quentin can hear.
I wasn't talking. I said I know for a fact that Ethan won.
Okay, but what was my question?
Can you say it again?
Maybe you're paying attention. Because remember, Quentin can hear you all louder than I can. So, what is the point from one wave to another wave? What do you call that?
Wavelength.
No, it's not a
Wavelength.
question because she already answered it. But wavelength. All right, what do you call the measure of a wave strength or the height from the middle to the top? A. A.
Altitude? No.
You went for a wave?
A starts with an N.
A.
So
The measure
wave something?
is the measure of a wave strength. It's from
Amplitude.
what?
Amplitude?
Amplitude.
Ooh, spicy.
3.
That's form, right?
What? Lamar Jackson. 55.
What do you call uncle the energy required to remove an electron from an atom?
That's so.
E. No, I.
Ionization.
Good job.
I'm Jack.
That's rude. Oh, okay. What do you call the amount
That's
of
not-
energy
that's
required to
Hey.
add an
Have
electron?
I gotten points?
That's in it, though.
Have I gotten points?
I'm not sure.
I would say I have 20.
I thought we did.
I'm not even gonna get candy.
Okay. Alright, what do you call the amount of energy required to add an electron onto an atom? Electronegativity? No.
Electron
Electron Infinity.
My turn.
You know when we were doing that thing with Pastor Hammer, he's playing defense, and we had to come down to
Oh yeah.
Yeah. The only 2 times I missed was when I was
Heart rate.
That's just how bad I am.
Oh my.
I'm not very good at basketball.
I know.
You're the best. You're the best player on the team.
What is Avogadro's number?
I think it was
6.022 times 10 to 25.
360 win the one.
Oh.
I ain't doing that.
There's
I was from hitting the floor.
there's also YouTube of most of
This
the
doesn't sound very chemistry related.
Hey, we're listening.
I
We're
want to know
right.
how someone's body allowed them to hit their head on the top of the backboard on a 10-foot rim.
It just depends on how much your body processes pain.
And he was 6'1" by the way.
Alright, what is the theory or principle or law that says it is impossible to determine the momentum and position at the same time?
Heisenberg uncertainty.
Yep, Heisenberg
He's also
uncertainty principle.
that's like his vertical had to have been like 60.
What do you call the lowest energy state of a
Ground state.
what?
Ground state.
Alright, I get next one.
I would be worried too if I was Jamie.
Kobe.
That was hard.
You do better at doing that.
Alright, what is the speed of light in a vacuum?
3.00 times 10.
Wait, what was that?
3.00
Okay.
times 10 to the 8.
Good job.
How fast the dust is moving.
What? Don't go.
I will hate you, Chris. What am I doing? I'm not hitting this.
Alright,
Look at this!
what do you call a reaction that is able to occur without continuing outside help?
Okay.
Yep.
Spontaneous.
Spontaneous.
Generation. Spontaneous combustion.
What is spontaneous generation? Do you remember from last year?
Nope. I don't have to remember that anymore.
It's whenever life comes from non-life.
You know what spontaneous combustion is?
That sounds like something catching on
something
fire with
complex.
Do
oxygen.
you know that's happened to 50 people yesterday? They blew up.
That
Right,
sounds
no
absolutely
reason.
terrible.
Without a
What are
reason.
you doing?
Yeah, no reason.
What are you doing?
They just wanted to, I'm gonna get it right.
Obviously you do. I just pushed you. Alright.
Hey.
I missed 2 the entire time I've been here. I'm gonna get it right. She's gonna be like, what's pi to the 11th digit?
Alright. Who came up with the wave mechanical model of the standing wave?
Starts with an R?
Starts with an S.
Starts with an S.
Yes.
My turn.
Okay, say it then.
Okay, who came up with the wave mechanical model or the standing wave? I asked this yesterday.
Standing wave, it starts with an S.
Mm-hmm.
What's the first
Beef.
letter?
E.
Schrodinger.
Good job.
Beef stroganoff.
I told you.
That's how I remember that.
Good job.
Step.
Very strong.
Step back.
You go from 18 to 2
Oh,
to nothing. He
Alright.
got 2.
who came up with the particle theory of light?
My turn.
Let's start
It's gotta be
with. Let's start with.
East.
Let's start with.
His last name starts with N.
Oh, my.
Isaac Newton. Girl.
In case you want to know. I know you were one off.
That was hard to throw. I went to the board.
What's the equation for specific heat?
That's 19. That's 19. That's open down for 19.
No one cares.
Just for down
It
Just
is
take your 19 and sit down.
It's
20.
the C equals Q over M times the change in temperature.
Good job. So
There's a country called Baja, California.
No, it's
Baja,
part
California.
it's part of Mexico.
It's just a
wait, you're talking about
Baja.
Baja, California?
Yeah.
Yeah.
Ethan, what is Baja, California?
It's
You
part of
should know.
Mexico.
I thought it was a Mountain Dew flavor.
It's a peninsula.
It's a peninsula. It's not. It's part of Mexico.
I thought it was a Mountain Dew flavor.
This is.
No, it's Baja Blocks, my bad.
Alright. Alright, what is, let's see, what is Charles' law?
Okay. I hope I get boils. Look at all this.
Y'all been doing good. Makes me feel
Alright, what did you ask?
Charles' law.
That won't work.
Charles gas law?
Yep.
V1 over V2 equals V2 over T2.
What was that?
V1 over T1.
You said V1 over V1.
T2.
Okay, you did not say it like
You
that.
said V1 over V1. For the win. Hits the backboard.
There goes all.
Alright, what temperature scale do you have to use with Charles' Law?
Let's start with
Temperature scale,
the one that
Ethan.
measures temperature.
Kelvin.
What do you do
Probably
in
be the
Kelvin?
last one about to do time for, I'll do one more for Jamie, so it's fair.
Wow.
Alright, Jamie, what's
Take
the
that.
this
I'll
equation?
take that.
That
No, no, no.
is a nine.
Don't want like I'm picking my hoodie up and
What
it's
is
so
that?
much I can't help it.
What?
What does it start with?
I.
The ideal gas law.
Who you have?
Boy diabetes.
Who'd you have?
I don't know. I didn't count points.
You're not gonna count points.
I didn't want the game.
I guess I win. You want to say
No,
anything?
James is the winner.
Jamie got them 50.
Alright, add your points, Cassandra's spell done.
I get 3 games.
I have
Okay, hang
13.
on. Alright, so, if I don't give you homework and I feel better about it, are you still going to study?
I'm going to tell you either way.
Study it
To
a
be
lot.
honest,
Study, what?
I said to be honest, no. I said it.
What'd you have?
It's
Okay.
an exam question.
Okay, make sure you're studying.
You
Alright,
can
so
go
no
higher.
homework then.
Does it look like I've been sweating all the
I
time?
got 49.
Ethan, does it look like I've been sweating?
Alright, Chris, scoot over so I can talk to Quentin really quick. Alright, Quentin, to make a note as well, this is Boyle's Law, specific heat, Charles' Law, ideal gas, Charles' Law in here, Charles' Law in here as well. Ideal gas law, combined gas law, be sure to email me if you need help from Chris, do not do that. Alright, anyway.